After completion of this chapter, the student should be able to use a plotting sheet to construct the relative motion triangle and identify the sides and angles. Determine course, speed and aspect of other ships from true and relative plots. Determine CPA and TCPA from true and relative plots. And use a relative plot to determine the alteration of course or speed needed to achieve a required CPA. This CBT is not an ARPA simulator, and therefore it does not meet the requirements set for ARPA training. However, after successful completion of this CBT, it will refresh your ARPA knowledge or prepare you for the required simulator course complying with IMO requirements for ARPA training and certification. This course can be obtained at Seagull RS Training Centre in Horten, Norway, or any other approved training centre. To fully understand the ARPA, it is necessary to fully understand the principles of plotting, and therefore this course will start with a brief repetition of the fundamental plotting principles. Since radar was introduced on commercial ships, various plotting devices have been introduced to reduce the burden of manual plotting on the navigator, and also to increase the accuracy of the final results, which is a very important aspect of plotting. Plotting has several purposes. It can show us whether danger of collision exists, or how close we will pass a target, CPA, and how much time before this will take place, TCPA. A plot will also deduce the other ship's course and speed, and finally calculate the target's aspect. The plotting process can be divided into 4 separate operations. Detecting the presence of a target. Selecting targets that require closer observation. The process of observing and recording the target's position, bearing and range over a period of time, the plotting interval. The plotting of these positions and calculation of the target parameters, CPA, closest point of approach, TCPA, time to closest point of approach, course, speed, and aspect. There are 2 main methods of radar plotting, relative and true. Both plotting methods can supply the same required information. Which method is selected depends on the preference of the navigator. On the following pages you will be shown a step-by-step demonstration of each plotting method. We will now go through a step-by-step demonstration of the relative plotting method and the construction of the relative plotting triangle. In relative plotting, own ship position will always be in the center of the plotting sheet. A plotting interval of 6 minutes makes it easy to convert speed to length and vice versa. 1 ring on the plotting sheet is equal to 10 knots. To make things a little easier, we'll say that own ship course is 000 degrees and speed is 10 knots. The vector in the center of the plotting sheet represents own ship course and speed. We made the first radar observation of the target at 10:30 hours, bearing 40 degrees and range 8 nautical miles. Let's name this plot O. Next we draw own ship course and speed vector so that it ends in O. The line from W to O is the first side of the relative motion triangle. One vital condition for the validity of the plotting results is that both own ship and target ship have kept course and speed for the entire plotting interval. If we take a control observation after approximately 3 minutes, we can use this to check that the target ship has not changed her course or speed. After 6 minutes we make a second plot with bearing and range obtained from the radar, and we name this A. The target's echo has moved from O to A in 6 minutes. As we can see, the line from O to A goes straight through our intermediate plot, and we can assume that the other ship has kept her course and speed. The line from O through A represents the relative motion of the target. We have now created the relative motion triangle, where the side WO represents own ship course and speed. The side OA represents the target's relative course and speed. The side WA represents the target's true course and speed. We find that the target's true course is 272 degrees and speed 22 knots. Let's continue from the previous page and demonstrate how you find the CPA, TCPA and aspect of the target ship. CPA, or closest point of approach, indicates a target's expected shortest passing distance. As you can see from the illustration, we find that the CPA is approximately 3.7 nautical miles. TCPA, or time to closest point of approach, indicates the expected time until the target reaches the CPA. If the plotting sheet has a logarithmic scale, we can use this to find the TCPA, or we can calculate it manually. The manual calculation of TCPA is as shown. The distance, 4.8 nautical miles, is measured from point A to the CPA. The speed of 23 knots is the relative speed found by measuring the length of the line OA. We then have to multiply by 60 to convert the result from hours to minutes. The aspect of the target appeals to a lot of navigators because it closely relates the visual scene to what is available on the radar. It answers the question, which sidelight would be visible if seen out of the wheelhouse window? Therefore, the calculated aspect can be a very useful piece of information required from plotting. Definition of aspect. Aspect is the angle measured at the target between the line of sight line from own ship and the target's fore and aft line. The aspect is defined as red or green, dependent on which side, and is measured from the target's fore and aft line from dead ahead to 180 degrees on either side. In true plotting, own ship will move across the plotting sheet as opposed to relative plotting, where own ship always will be in the center. You will now see a step-by-step demonstration of true plotting. We start by drawing up own ship's course through the center of the plotting sheet. Then we make a plot of own ship, somewhere on that line. This point represents own ship position at 1150. At 1150, we take the first bearing and range of the target. We plot the bearing 45 degrees and distance 8 nautical miles from own ship position. Before making the second plot, we have to move own ship forward a distance of 1 nautical mile, corresponding to the distance travelled in 6 minutes. From this position, we can make our second plot of the target. At 1156, we take the second bearing and range of the target. True bearing 38 degrees and distance 7 nautical miles. By drawing a line through these two plots, we will get the target's true course directly. The distance between the two plots represents the target speed. To find the CPA and TCPA, we have to construct the relative motion triangle. Since we know the target's true course and speed, we can find its relative motion by drawing a line representing own ship course and speed. This line represents the target's relative course and speed. As you can see, we have now created the relative motion triangle, but this time the relative motion side was the unknown. Now you can find the CPA and TCPA. True plotting does not have to be done on a plotting sheet. You can just as well use any piece of paper or plot directly in the chart. It is, however, important to use a suitable scale for the task. We can get the exact same information from true plotting as from relative, and it is up to the preference of the navigator which method is used. One vital condition for the validity of the plotting results is that both ships have kept their course and speed the entire time between the two plots. We can never know if the other ship has changed her course or speed, so we must use more than 2 plots in sequence in order to check for this. We have plotted another ship on our starboard side, and as you can see from the relative plot, we are on a collision course. A change in own ship course is a very effective way to keep clear of other traffic. We decide that we want a CPA of 2 nautical miles. Now we have to find out how much we must change our course to achieve this. Let's say we need 3 minutes to do the actual plotting, so we have to move the target forward a distance corresponding to 3 minutes. From the point C, we draw the new line of relative motion, making sure it passes 2 nautical miles from the centre. We then parallel displace this line through A. To find our new course, we have to alter the direction of own ship course vector so that it closes the new relative motion triangle. As you can see, we must change our course to 0.55 degrees to achieve a CPA of 2 nautical miles. Let's start with the same plotting situation as on the previous page, only this time we want to use a speed reduction to achieve a CPA of 2 nautical miles. We follow the same procedure as for the change of course example, and give ourselves 3 minutes for the plotting. This time we just change the length of own ship vector until it closes the new relative motion triangle. The length of this new vector represents our new speed, which will be approximately 7 knots.